So you wander into a hardwood forest, like in eastern North America, right? And you expect to see standard mushrooms. But instead you find this thing that looks like, well, a frozen waterfall.
Or like a shaggy white ghost clinging to a dead tree.
Exactly. And, that brings us to our deep dive for today. We have this really amazing stack of research on Hericium americanum, which is also called the bear's head tooth mushroom. And our mission is really just to uncover its bizarre traits and its unique chemistry.
Yeah, and right off the bat, we should probably set aside its famous cousin, lion's mane.
Right, because lion's mane is just that single solid globe.
Exactly. But Hericium americanum is this highly branched hardwood-eating specialist, which is a huge clue to how bizarrely engineered it actually is.
Engineered how?
Well, it relies on strict gravitropism. I mean, the spines grow maybe 1 to 4 centimeters long, but they always point perfectly perpendicular to the ground.
So no matter what weird angle the host log is resting at, they just point straight down.
Right, perfectly straight down. And that guarantees its spores can fall freely into the air currents below.
Wow. And because they point straight down and overlap, they kind of create this dense, gravity-defying apartment complex.
Yeah, an apartment complex is a great way to describe it.
It's a literal cave system. Like it's custom built for these specialized mycophagous insects.
The cyst beetles, right.
Yeah, the cyst beetles. They basically use it to safely raise their larvae, completely shielded from the elements.
Which gives us this really fascinating dual defense system. I mean, on the outside, it builds this protective physical fortress for symbiotic beetles, but on the inside, it houses an even more robust chemical armory.
Okay, so let's get into that chemistry.
Yeah, so its metabolic engine is dominated by this neuroprotective and antimicrobial compound called erinacine P.
Right.
And what makes it so unusual compared to other Hericium species is just its internal metabolic stubbornness.
Yeah, the research actually notes that when scientists use surfactants,
Basically, those harsh, soapy chemicals designed to rip open cells.
right, they use those to pull out compounds. And most Hericium species lose like 83 to 100% of their erinacines. But bear's head tooth just shrugs it off.
It completely resists that reduction. The fungus possesses such a tightly locked cellular vault and a highly stable internal regulatory system that the chemical stress just doesn't break it down.
But wait, let me push back here for a second.
Oh, sure.
If it actively resists extraction, isn't that a bad thing? I mean, if scientists can't easily break open the vault to get the medicine out, why is this stubbornness a positive?
Well, for pharmacologists, stability is basically the holy grail.
Oh, yeah.
Because if a compound breaks down the second it faces chemical stress, you just can't turn it into a reliable drug. So since this biosynthetic pathway is so incredibly robust, it has massive potential.
Potential for like stable neuroregenerative medicine.
Exactly. Medicines that can actually survive the really rigorous processing required for pharmaceuticals.
That is wild. And that resilience explains why researchers decided to really test its limits.
Yeah, they wanted to see what this reactive armory would do under bizarre environmental triggers.
So they grew it on Cheerios, literally the breakfast cereal.
Yeah, the breakfast cereal. They used what is known as the OS-MAC approach.
One strain, many active compounds.
Right. And by drastically changing its diet, they forced the fungus to unlock completely dormant genetic pathways.
Just from Cheerios.
Just from Cheerios. It caused it to synthesize entirely new defensive chemicals, including a novel erinacine alkaloid and these chlorinated orsonols.
Okay, rather than just dropping those massive terms, let's look at what they actually do. These new compounds are specifically designed to shred Candida fungal biofilms.
Exactly. So by feeding it processed cereal, it essentially forged a brand new weapon against entirely different infections. It proves this organism is just a highly adaptable reactive vault.
Which is incredible. So its diet literally dictates its chemical output.
Oh, totally. And we are actually seeing these hidden pathways trigger in the wild, too. Scientists recently confirmed a rare, visually striking pink variant.
The Varrosium.
Yeah. And we still don't really know exactly what specific environmental stressor or wood chemistry flips the genetic switch to turn it pink.
Wow. It makes perfect sense why indigenous peoples call them ghost teeth.
Oh, absolutely.
They use the dried, highly absorbent spines as an antimicrobial styptic poultice to stop bleeding and fight off infections. And today, chefs even use its stringy texture as a vegan crab meat substitute.
While science is banking on its chemistry for the future of brain health, it beautifully bridges that gap between ancient forest ecology and cutting-edge pharmacology.
It really does. So here's a final thought to leave you with today. If a mushroom can completely alter its internal chemistry to forge novel antibiotics just by being fed breakfast cereal, what other dormant life-saving compounds are hiding inside forest fungi, simply waiting for the exact right environmental trigger to wake them up?